Welcome to SND College of Engineering and Research Center. In previous lecture, we have studied determination of the resultant and resolution composition of the forces. But whenever we are finding the resultant of the force system, there are two cases. The first case is the force system is concurrent force system. Whenever there is a concurrent force system, means all the forces acting at the same point. In other words, we can say that if the line of action of all the forces is passing through a single point, it is also called as a concurrent force system. In concurrent force system, it is very easy to determine the resultant and its position. The determination of resultant, we have seen the steps. We will resolve all the inclined forces F1, F2, F3 in horizontal and vertical components. For horizontal component, we will use force into cos of angle from horizontal reference line, and for vertical component, we will use force into sine of angle. As in concurrent force system, all the forces are acting at a single point. That's why whatever we will get the resultant R after using this formula under root of summation fx square plus under root of summation fy square, this R is also acting on the same point on which all other forces or its subordinates, other forces are acting. Means, as again concurrent force system, the point of application is same and line of action of all forces is passing through the single point. That's why the resultant of the force system is also acting on that same point. If the resultant is this, then it will also act at point A as that of all forces are acting. But when the force system is non-concurrent, in non-concurrent force system, for example, a bracket is there. This bracket force F1 is acting at point A, force F2 at an angle of theta acting at point B, and one another force F3 is acting at point C. Then how to find the resultant? Determination of magnitude of the resultant and direction is same as concurrent force system. The same two steps will be followed. What are the steps? The first step is we will resolve all the inclined forces. After the resolution, we will find algebraic sum of horizontal forces, summation fx, algebraic sum of vertical forces, summation fy. And after determination of summation fx and fy, we will use this formula R equal to under root of summation fx square plus summation fy square to determine the magnitude of resultant. And for direction alpha, we will use alpha equal to tan inverse mod of summation fy divided by summation fx. Same process, but here from magnitude and direction, we don't know at which point the resultant is acting. We don't know. In concurrent force system, it is obvious that the resultant is also acting at the same point as that of number of forces are acting. But in non-concurrent forces, we know the magnitude of the resultant with the help of this formula. We know the direction alpha, but the point of application of the resultant and position of the resultant acting on the object we have to find. To determine the position of the resultant for non-concurrent force system, we have to use the concept of moment. What is meant by moment, first of all? It's producing the rotation of the object. The moment of the force is the cause of the rotation. With whenever forces are acting and that forces are unbalanced non-concurrent forces, then along with that linear displacement, forces are also trying to rotate that object, and that rotation may be with reference to any point on the object. The moment producing the rotation, that's why the rotation may be of two orientation, anti-clockwise rotation or clockwise rotation. Clockwise, anti-clockwise, clockwise rotation. What is the definition of the moment? How to find the moment? The moment is the product of force and perpendicular distance of line of action from moment center. Then what is meant by moment center? The moment center is the point about which body is trying to rotate. For example, bracket ABC. If you will consider the point C is the point of rotation, then this C point is a moment center. For example, force F1 is acting at me and this length is 2 meter. Then the moment about point C, moment about point C is equal to F1 into 2. Moment is the product of magnitude of the force and perpendicular distance from moment center. Likewise, moment center, this perpendicular distance of line of action of a force from moment center is called as moment R. Moment center and moment R. It is very important point is that whenever same magnitude of the force changing its position, for example, very easy example, how moment is changing. Assume that this force now F1 is acting at a distance of again from 1.5 meter. Same magnitude, but this rotation will increase with F into perpendicular distance. Perpendicular distance from moment center is this much is 2 plus 1.5, 3.5. Moment center is C. As the position of the force will change, the magnitude of the moment will change. Means moment is fixed for a particular point. That's why we already learned in previous videos that moment is a fixed vector. Moment is a fixed vector. How to calculate the moment for the force system? When single force is acting, that is very easy. If I want to find moment about point A, then moment at A, if this is vertical distance is 5 meter, then moment about point A is force F1 into perpendicular distance. Determination of the perpendicular distance in moment calculation is very important, because students are doing so many mistakes in calculation of the perpendicular distance. As the force F1 is acting at point B, students are saying, will say the perpendicular distance is 1.3 for one A. Student will say the perpendicular distance is 5, but actually it is wrong, because the perpendicular distance should be from moment center. If we will calculating the moment about point A, then A is our moment center, and from A I will calculate the distance of force F, and this force F should be considered along with the line of action of the force. To draw the perpendicular, what is required? A This is the point, this is the force. But when I will extending the line of action of the force, this line of action of the force is also passing through our moment center A. That's why the perpendicular distance is 0. Perpendicular distance is 0. In two cases, the moment of a force is 0. The first case is when moment center and point of application of the force is same. For example, we will see here moment center and point of application of the force is same. It is point B. If my moment center is B, then MB is 0. Why? Because my force F1 is acting at B. It is the first case in which the moment due to that force is 0. Moment, what is the first case? Whenever moment center and point of application of the force is same, at that time the moment is 0 because the perpendicular distance is 0. Second case, when moment is 0, whenever the line of action of the force is passing through moment center. For example, I will consider this force F2 here. F2, if F2 is a force, then according to law of transmissibility of force, I will extend the line of action. It is a line of action. According to law of transmissibility of force, a force can be shown anywhere along the line of action. This force F2 along the line of action I can show here. That's why again the perpendicular distance is 0 for force F2. F2 into 0. It is very important cases. The moment will be 0 when the point of application of the force is moment center itself. And in second case, the moment of the force is 0 when the line of action of the force is passing through moment center. Whenever the force is at different position from moment center, we have to see whether the line of action of that force is cutting the moment center or not. If it is cutting the moment center, then the moment due to that force is 0. So, for the calculation of the moment, it is the product of magnitude of the force and perpendicular distance from moment center. As moment is purely producing rotational effect, either object will rotate in anti-clockwise and clockwise. These two are the possibilities. So whenever number of forces are acting, for example, same bracket we will consider. Whenever the number of forces are acting, we will F1 force, distance is 1 meter, here 1 meter, and this distance is 2 meter. Whenever number of forces are acting, then we have to find the algebraic sum of the moment. If I want to calculate the moment about point A, then I have to take the algebraic sum of moment due to force F1 and moment due to force F2. If we have to take algebraic sum, then sign convention is very important. So we have to fix a sign convention. We will consider the anti-clockwise rotation as positive and clockwise rotation as negative. I will calculate the moment about point A. This is point A, force F1. Force F1 into the perpendicular distance is 1 meter. F1 into 1. Whether it is clockwise or anti-clockwise, we will see. From this point, it is a fixed point. Moment center is a fixed point, and this fixed point is this force F1 is trying to rotate the figure in clockwise direction. That's why, according to our sign convention, the clockwise direction is negative. Clockwise direction is negative. Very simple. You can see with the help of this thumb, this knee will put at a fixed point, that is moment center. center, and this thumb is showing the arrow of this force F1, means the object will rotate like this, like this. It is clockwise. That's why the moment due to the force F1 is negative. So second force is F2, F2 into this force F2. It is acting at point C. For calculation of the moment, perpendicular distance is required, and for perpendicular distance I will extend the line of action. This is the dotted line of action, and I will put a perpendicular from point A. This is the perpendicular, and I require this line from point A. It is 1 meter plus 1 meter. It is 2. It is the magnitude F2 into 2. But what is the orientation? Whether it is clockwise, anti-clockwise, we have to check. Again, listen here. This knee I will put at moment center, arrow direction, and this thumb is same. Object is rotating like this, means it is anti-clockwise, and it is positive. If there is a third force, then same you have to calculate F3 into perpendicular distance, fourth force F4 into perpendicular distance. So for total calculation of the moment, we have to take the algebraic sum of moment due to all forces about a particular moment center. This moment center, if it is given in numerical, then we have to consider that point. If it is not given, then we have to assume that considering the A as a moment center, or B as a moment center, or C or any other point, depending upon the diagram and given force system. So we have to find the algebraic sum of the moments. While calculating the moments, the sign convention is very important. We are considering anti-clockwise as positive and clockwise as negative. You may use reverse also. The magnitude will not change, orientation also will not change, just positive negativity we have to mention. Either positive, if you will take the reverse, then if anti-clockwise, the algebraic sum of the moment is anti-clockwise, then answer will come exactly opposite of whatever we have chosen the sign convention. So the moment calculation is very important point. We have to find perpendicular distance, and determination of the perpendicular distance is very important point. Very important point. We have to remember 2 points. Whenever a force is acting at some point which is having some distance from the moment center, then we have to extend line of action. Extension of the line of action is very important point. After extension of the line of action, we will drop a perpendicular from moment center to that line of action, and we will measure that perpendicular distance. That is the force into that distance will give you the magnitude of the moment. And after that calculation of this, we have to see the orientation of the moment, whether it is anti-clockwise or clockwise. Now, to find the position of the resultant in non-concurrent flow system, we have to use Varignon's theorem. Varignon's theorem. It is also called as theorem of moments. What is Varignon's theorem states? Varignon's theorem states that the algebraic sum of the moments of all the forces acting on the object about a moment center is equal to the moment of resultant about the same point. Again I will repeat. The algebraic sum of the moments due to all forces acting on the object about a moment center is equal to the moment due to its resultant about the same point. What it will give you? For example, I will write here one bracket A, B, C, D, force F1, F2, F3, F4. These four forces are acting. Assume that we have to find. We will. We have to find the position of resultant. Now, how to find position of the resultant? For finding the position of the resultant, we will first find the magnitude and direction of the resultant. How to find? Very easy. As previously we have shown, we have seen the methods to calculate the resultant of the force system. We will see whether forces are inclined or not. If inclined, we will, for example, on another force I will add F5, it is having angle of theta. If it is inclined, then we have to resolve in horizontal and vertical component F5 sin theta, F5 cos of theta. Then I will find summation fx, I will find summation fy. Before resultant r equal to under root of summation fx square plus summation fy square. Then I will find the direction of resultant alpha equal to tan inverse of mod summation fy divided by summation fx. After the calculation of this, we know that what is the magnitude of the resultant and what is the direction of the resultant. And from the sign of summation fx and summation fy, we can also know, we can decide in which quadrant that resultant is acting. But at what position that resultant is acting? It is very important question. Whether it is acting at B, C, B, A or at some other point on the object. To have the location of the resultant, we have to use the Varignon's theorem. How? Now, I will again state the statement. The Varignon's theorem states that the algebraic sum of the forces acting on the object, the algebraic sum of the moments of the forces acting on the object about a moment center, algebraic sum of the moment due to all forces. Algebraic sum of force means, for example, I will say my moment center is C. This C. Then algebraic sum of the moment will be F1. Assume D1 is the perpendicular distance from C. F2, D2. Then F3, D3, then F4, D4, and F5 has two components. That's why we write F5 into cos of theta and F5 into D5 D5x and F5 sin of theta D5y. It will be positive, negative, positive, negative, positive, negative. Because if it is anti-clockwise, then it is positive. If it is clockwise, then it is negative. It is the algebraic sum. Addition of all the moments. This algebraic sum is equal to the moment due to the resultant. For example, if this is the R, it is acting in fourth quadrant and it is the alpha. We know that what is the distance of this point and position. So I will consider capital D as a perpendicular distance of the resultant. Perpendicular distance of the resultant from moment center. My moment center is C. That's why I will calculate the moment due to the resultant R. What is the moment? It is the magnitude of the force. Here magnitude is R into perpendicular distance D. R into D. It is very easy. Now we can find this algebraic sum that will equal to R into D. R is known from formula R equal to the root of summation fx square plus summation fy square. Then we can easily find the D. What is this D? D is this perpendicular distance of the resultant from moment center. You can find with respect to A. If I need distance of this resultant R from point A, then I will first find the moment due to all these forces about point A. In this case, my moment center is point A. Then I will find algebraic sum, that I will equate R into D, and that D is the perpendicular distance from moment center point A. So the significance of the moment principle or Varignon's theorem is that we can easily find the perpendicular distance of the resultant of non-concurrent force system from the moment center. We have to keep in mind, if I require the perpendicular distance from point B, then I will consider the B as a moment center. If I require the perpendicular distance from point D, then I have to take the moment about point D. From the moment center, the Varignon's theorem will give you the perpendicular distance of the resultant. So, where we have to use Varignon's theorem? Whenever the position of the resultant is required to find, we have to use Varignon's theorem. Again, I will explain what are the steps. First, we will find the resultant R and its direction alpha. For determination of R and alpha, we have to follow the same step as previous POC. Means we will resolve all inclined forces. We will find the algebraic sum of horizontal forces and vertical forces, that is summation of x and summation of y. After this, we will find R equal to under root of summation of x square plus summation of y square. Then we will find alpha equal to alpha from the formula alpha equal to tan inverse summation of y divided by summation of x. Now magnitude is known, direction is known. Now I require perpendicular distance. For perpendicular distance, I will choose a moment center, a point from which distance need to find. In numericals, sometimes it is mentioned that determination the position of the resultant from this specific point, either A, B, C. If it is given, then I will take the moment at that point only. And if it is not given, then we have to write considering the point A is a moment center or B as a moment center. Because the point which is considered the moment center is the reference point from which we will measure the distance of the resultant. So assume that we have to find the position of the resultant from point A. Then I will calculate the moment of all forces with reference to point A. I will find the product, force and perpendicular distance. I will see whether it is anti-clockwise or clockwise. Then accordingly, if it is anti-clockwise, it is positive, clockwise is negative. Algebraic sum is known, then I will equate that algebraic sum R into D resultant into perpendicular distance, and R is known already from the formula R equal to the root of summation of x square plus summation of y square. So we can easily find that D, that is perpendicular distance of the resultant from moment center. Now there is one very important concept, that is called the couple. What is mean by couple? In force system, there is a possibility when two unlike parallel forces of equal magnitude acting on the object separated by finite distance said to be forming a couple. Couple is means, for example, it is 10, it is 10 and this distance is 2 meters. Then it is forming a couple. What is couple? When two unlike parallel forces means direction is opposite, acting on the object separated by finite distance form a couple. The magnitude of the couple is product of force and distance between them. Means force magnitude of the couple will be 10, this force, and for distance between them, that is 2, that is the magnitude of the couple. The unit is Newton meter, as it is product of force and distance, same as a moment. because the unit of the moment is also Newton meter. Moment is the product of force and perpendicular distance. Force unit is Newton and distance in meter. So 20 Newton meter is the couple. This couple is producing pure rotational effect. Rotational effect. Very best example is tap. When we are opening and closing this tap, we are applying two equal forces in opposite direction, which will rotating that, and this rotation is due to the application of the couple. Couple is a free vector, means the effect 20 Newton meter does not change if the position is changing. That's why in some force systems we have to consider couple also whenever it is given with along with its, for example, assume that a bracket A, B, C is there, force F1, F2, F3 is acting, and also a couple having magnitude of C is acting. Or you like two couple, it is C1, it is C2. When I will calculate the resultant, in resultant I will not consider the couple. Why we are not considering resultant R? Because in couple two unlike parallel forces of equal magnitude. Unlike parallel forces of equal magnitude, both are cancelling the effect, linear effect. That's why we will not consider in the resultant. But in moment we will consider as it is. For example, if it is a 3 meter, it is 5 meter, then I will calculate the moment about point B, moment about point B. I will find the negative sum of all the forces D1, F2 into 0, F3 cos theta into D3, F4 sin theta into D4. These are the forces. F1 into D1, moment center is B, means F1 perpendicular distance for F1 is also 0 because line of action is passing through moment center B. When I will extend this 0. F2 for F2 it is 0. For F3 it has two components, horizontal and vertical, F3 cos theta, F3 sin theta, that will I will consider. And depending upon clockwise and anti-clockwise, I will consider the sign convention. I have put assume positivity or negativity. We will see later on. Now I have to consider these two couples. What is the couple? Couple is when two unlike parallel forces are acting on the object separated by finite distance form a couple. So directly the magnitude of the couple we have to consider in moment calculation. Is C1, it is clockwise, therefore it is negative. Then I will consider the C2, it is anti-clockwise, I will consider it as positive. Once the moment calculation is over, I will use Varignon's theorem. Couple is a free vector. The resultant of the couple is 0. We are not consider the linear effect of the couple. And the moment of the couple is independent of the distance. Independent of the distance is very important point. It is a characteristic of the couple. Means this C1 whether I am showing here or here or here, the effect doesn't change. Because in moment calculation we are not considering the location of this couple. We are not interested to find what is the distance from point B or point C. Just we are considering the magnitude of the couple C1. I will see whether it is clockwise or anti-clockwise. Depending upon that, if it is anti-clockwise, I will consider it as a positive, and clockwise it is, then I will consider it as negative. Then after the calculation of the moment, I will use Varignon's theorem to determine the position of resultant with respect to moment center. Okay, we will see in next lecture the numericals on Varignon's theorem and how to calculate the perpendicular distance from the moment.